Hello everyone, I'm back again. So before my talk, have you checked the translation there? Is it good? Because oh really? Because I paid a lot. Last 2 years I just used a version from 讯飞同传. I paid them maybe 10 RMB per hour. This time it's 40 hours because they claim to be introduced LLM. And I do drag all the KiCad phrases into the database. However, it still cannot recognize KiCad. Is there a KiCad there? I've tried 2 hours last night in order to make KiCad to be recognized, but still doesn't work. Anyway, so I don't think it's open source language model. It's called 科大讯飞, if you're aware of that. It claimed to be the best, translator models in China, but it still doesn't work. Okay, this is just a joke. So today I'd like to talk about something about Huaqiu's distribution version, and also a very interesting topic about the AI Copilot. Let me ask you questions. How many of you have used AI in your daily life? Can you raise your hand? Okay, almost all of you, right? And how many of you have used AI in your electronic design work? Please raise your hand. I see only Peter. Maybe you don't trust AI. So do I, right? Never trust AI in electronics design, right? Because I think it's still a long way for AI to landing in the engineer landing, right? But it doesn't prevent us to try AI things. So that's what I'm going to talk about today. We are going to embed an AI Copilot within KiCad, interactive with schematics and PCB. And we are building some interesting applications. For example, image to symbol, image to footprint. I will show you later. This is all designing in KiCad distribution version. So if you have an interest, you can try that. Okay. So let's first start it with today's topic. So we have here's the schedule. So first, I will talk about what is the KiCad distribution version. What is the difference between the KiCad distribution version, Huaqiu's distribution version, compared with the May branch. And second, I will talk about what we call cloud-based component library and module library. Maybe Peter, you will be also interested in that. And third, we'll talk about AI Copilot and then its application in KiCad. Okay. So why we need a distribution version? I have answered this question, in last KiCon, right? So actually, we are not just simply doing a fork for KiCad. We are going to make this Huaqiu's distribution version as a complement for Chinese users. What we are doing here is one, so we are trying to address some issues which could not be merged. It could never be merged into the May branch. For example, everyone knows there is a great firewall problem issue, especially for you guys who first come to China. You cannot access YouTube, you cannot access to Twitter or GitHub, right? So do we. So in KiCad, we have plugins, right? Because we cannot access to GitHub, so we cannot download plugins. That's why we need something special for Chinese users. That's one reason. And the second reason is that we're trying to make this distribution version as a trial run for some new features. For example, the dark model Seth just mentioned, right? So we implement the dark model into our Huaqiu's distribution version so that users can use that. Also, the Copilot is also one of the purpose. We are trying to build our version to make more people to use some new modern features. You like it or not, it's a new thing, right? Okay. The last thing is, because Huaqiu, Next PCB, we are a board manufacturer, we are SMT manufacturer, right? So my dream is always to connect supply chain, design, and manufacture together. So I'm not going to make or position KiCad just as a design tool. I want to position it as a core platform which could integrate with supply chain, that's component selection, right? And do the design. And you one click, you can send your design to manufacturer for fabrication. Oh, that's the third reason why we need that. So just have a very quick review of what we have done. Oh, dark mode. So we have implemented this since KiCad 8. I'm pretty sure a lot of Chinese users have done that. Unfortunately, KiCad 10 will implement this feature as well. Then that's the meaning of a trial playground, right? We have proved that people like that. So we are going to implement into the main branch, right? That's okay, this is one of the feature. And the second feature is about plugins. I'm not sure any of you have tried Huaqiu's distribution version, because if you use Huaqiu's version, you can easily download plugins no matter where it locates. What we have done is we just crawl these plugins into Gitee, and we have a URL or JSON file which can help you to connect to the Gitee repository for downloading these software. So if you are using the main branch KiCad, it's okay. You can still use this link. You just add it into the plugin manager, and now you can download plugins even with the KiCad main branch inside China. Okay, this is another thing we are building. So we are building a portable KiCad. So I'm not sure how many of you have installed a lot of different versions in KiCad. For me, I at least install maybe 5 to 8 versions from KiCad 8 or KiCad 9. And for KiCad 9, I'll install different minor versions from 9.05, 9.06. But sometimes you will find if you install different versions, there will be some conflict, right? So that's why we build this. So for every minor release, you just click this portable version, you can download it, you can use it without any installation. So again, the configuration files we only have one common configuration file for a big release. But anyway, you can build your own release, you can download different release and just open and click and use it. Okay, and this is a plugin we have made inside KiCad, so it's open for everyone. It could be used for component search. It's based on a very big database. I think the database also have open APIs. I'm not sure. Maybe Alex, you have used that. Maybe some developers have used not only this plugin but also some APIs to query components and some supply chain informations. You can always install it through the plugin manager. And again, this is the DFM plugin. So I'll talk about DFM things, but so first the DFM plugin. So we embedded plugin inside PCB. So when you click the DFM check, we will wrap the Gerber files and send to the backside server, and it will detect all the manufacturer related issues and come back to KiCad. You click and you will find. There is a video here. You just click and you will check all the manufacturer issues and let you identify these issues within KiCad instead of going to another software for issue checking. Okay. Advertise time. So if you have not tried Huaqiu DFM, I'd suggest you do, because it is a good thing. If you see the image, yeah, this is an advertisement for anyone who is in China or out of China. You should try this Huaqiu DFM. It's a very cool software. It's free, and you can use that as viewer because it supports different formats of EDA tools. AD, Allegro, Pads, Gerber. You just drag your original files into DF file. It will convert into some version, render it, and just see the file. And also you can do the bareboard design. You can do the SMT check within this software. And one of the features I'm recommending here is the Gerber or ODB plus compare. So you use this file, you just import 2 different versions of Gerber's or ODB++. You can position your file and do the comparison. This feature is especially used for when you are converting some format. For example, between Allegro or Altium or KiCad. You import an Altium PCB into KiCad. You're not sure if it is imported correctly. Then you just output your Gerber and do the compare within this software. So we are a contributor for ODB++ in KiCad, right? So this is a tool we use when we debug this feature. Okay, this one is simple. We have a plugin in PCB which you could use to be one click generate the Gerbers and everything, and just upload to HQ PCB for an ordering. maybe this one is open for everyone. It's a plugin. Maybe it's already obsolete because in Huaqiu's distribution version, we built a new feature there. So we have an icon there. If you click it, it will dynamically get your parameters within PCB and get your BOM, and we will get a quotation for your PCB or get a quotation for your SMT, and you can directly, make an order, and you can track your orders within KiCad. So it's like it's a simple technology. We just embedded web view inside KiCad, but to make it more integrated. So this is one feature of our distribution version. Okay, this is pretty much the simple difference between the main branch KiCad and the Huaqiu's distribution version. And now I'll introduce the second topic. Maybe you are more interested with. I will do some lab demo later if we have time. But first, let's see what's cloud-based component library and module library. So I've showed this image last year. So it describes what is the complete component. I'm pretty sure maybe many of you sitting here is always checking, do we have a component concept in KiCad, right? But the answer is actually no. So the symbol library and the footprint library is separated. We do have a database library. We have HQDFM. That's cool. But basically, we don't have certain component concept which integrates all these data together from metadata, parametric data, datasheet link, schematic symbols, 3D models, simulations. We are now always putting some metadata inside the schematic symbol, right? Always database library, we have a CQ table. We put everything there and linked with a symbol or footprint. It's good, but it still takes some time for you to learn, right? The learning curve is a little bit slow, right? It's not easy for you to build the database library. So this is what we call a component concept. So what we are doing is in the distribution version, so we embedded a panel, a component panel there. So if you have a chance to download our version, so if you open the schematic editor, you will see a panel there. It's actually a cloud-based library. So we have a team, to build libraries. We work with, this NCTI, which is a local component provider, symbol provider. He will deliver speech soon. And we will show all these components there. And you can directly place that into the schematic sheet. So it basically integrates everything from metadata, from symbol, from footprint, even for 3D models. So when you place this symbol into your schematic sheet, everything, the parameters, everything, and the footprint link is there. So you don't need to configure a table, right? You just search the component. If it's okay, you just place component into the sheet. It's a little bit like the JRC PC EZEDA, or a little bit like the Altium's content vault. That's one feature of the component library. So it's not only the library. Oh, one more thing. So we even build a private library because it's online. If you have your own account, you can upload your own libraries, and you put your own libraries onto the server, and you can use it everywhere. So Peter, so you can also try this if your library is not so big. Okay. Another feature is I'm talking about, we are integrating third-party solutions into the library panel as well. So this is our sponsor. You can see their solution at the back of the hall. Oh, there are a specialized team which is dedicated to do component libraries and mechanical libraries. We integrate their solution. The quality of their library is really very high. This library showed here, it has everything, including the step models. Yeah, so you can just log in and just use their component libraries. You can download it, you can place it into a schematic sheet or place it into a PCB and just use their solution. Okay, another thing, we are not only build a cloud-based component library, we are also build a cloud-based module library. Since KiCad 9, we support design blocks, and KiCad 10, we support design blocks for PCB, right? So what we are doing here is we build a cloud-based library for modules, so everyone can just check and use that. It's dynamic. I will show you later. And you just directly place the module into your sheet in the form of snippet or in the form of a design block. So you can treat this as a existing module library. So someone draw the library and verify it. And if you find it's useful, you just directly place that into your schematic sheet. Okay, that's some content we are building. Okay, now let's come to the interesting part. AI Copilot and applications within KiCad. Let's see what we have built. So first, the Copilot want to say hi to everyone. So he is just a panel, he's a little robot. He is going to help you to design your circuit. Yep, let's see what we can do here. Yes, if you take a small video here, so we build a Copilot panel just like any other Copilot panel. But the beauty thing is we can interactive with schematics or PCBs with this panel. So if you don't know what the feature, what this function, circuit function does, you just draw a rectangle to include these functions and ask the AI. It will help you to answer your questions. You can answer questions, as you can see, for the selected circuit, no matter it's a schematic or it's a PCB. You might ask, how can you trust this AI, right? There is always hallucinations, I admit that. But the thing is that you don't need to trust it. You can treat it as a reference. Just think about it. What's your traditional way? If you have a new schematic, what you're doing is you need to check the data sheet of all the components if you're not familiar with them, right? And then with your experience, you figure out what this schematic does. So what LLM does here is just help you to fast accelerate this process. That's what we have to do. Yeah, you need to make decision by yourself, but with this Copilot, it can quickly help you to understand the circuit. Or it's not understand circuit, and you can understand component. You can find an alternative component. You can make some comparison between different components. You can do everything. You can even generate code with this Copilot, right? So this is what we have built. Let's see what it can do. So basically, it's a multimodal model. So you can also, just copy, paste an image. This is a KiCon image, and we just paste it into the panel, and you just ask questions about chips, about the functionality, about everything. So it supports images. Okay, this is video. So this Copilot talk with PCB. There's two ways you can do that. One way is just you make a copy paste of the image and put the image into the dialog and ask questions. Yes. Another way is you can just drag and select these components, and it could be a veer, it could be a track, and we will collect these informations for the object and send it to the LLM as a context, and then he will help you to answer your questions. The idea is very simple, but I would like to emphasize, trust yourself, don't trust the AI, but AI could help you to do something in some way, okay? Okay, and this one will be interesting. This one is, we made some lovely applications. Now, within this application, you can turn an image. It could be a table, it could be a pin graph. You can just copy the table or pin graph, the image to KiCad, and it will generate the schematic symbol for you, and you can directly place the symbol into the schematic sheet. So you don't need to configure any FP tables. You don't need to do, open a schematic library or something. You just put an image there, it generates a symbol, and you can place it into the schematic sheet. You can do this either in schematic editor or in symbol editor. If you are doing a big symbol like a FPGA, you have thousands of pins. The tough thing for you is just to collect these pin tables, right? So we can help you to address this issue. And the thing is that the correctness of the recognition is quite high. I could say 90% of the recognition is correct. So most of the situation, you can just, copy and paste the image, and you got a schematic symbol and use it. Okay. And this is the tough thing. Schematic symbol is easy because you just need to distinguish the pin name and pin number. We also trying to do the footprint generation. So according to the image, have you seen that image? According to the image there, it's a quite complicated image with a lot of geometries marked there. So we are trying to use the model, to distinguish all these geometries and put these parameters into the, like a footprint wizard. The difference here is that with footprint wizard, you need to manually input everything, right, into the footprint wizard. What we are doing is use the LLM to extract this information and put these things into the wizard and then automatically generate the footprint. Again, you can directly put it into a PCB or you can put it into a footprint editor. There are several steps there. You can do the manual check if it's wrong. So far, we support IPC compliant footprint like VGA, SOT, SOP, things like that. We still cannot, recognize any type of footprint like connectors. We cannot do that. It's too tough for LLM. Yeah, but we're trying to, make it better. Okay. Last one. This one is an test. It's not a mature one, but I like to show you there. We are using the LLM to generate a schematic for you. So I will show it later with a demo. So you just input your requirement. It could be English, Chinese. For example, I want to design a smart lock, and the LLM model will choose the correct module. At least the LLM thinks it's the correct module, and pick all these modules together and generate a structure diagram, right? Okay, and then you can place the diagram within KiCad. It's not just a root page. It's a complete sheet, included with modules, included with connections. You must ask, how can you guarantee this thing is correct? The answer is no. It could be wrong. It could be a lot of mistakes here. The idea here is we are trying to do some experiment. I'm not sure if this could save your time. For example, if you are a student or if you maker. So we are trying to emulate what you are doing when you do a design. In the traditional way, you copy and paste modules from your own design, right? So what we are doing here is we are trying to build some mature modules and let the big model to choose the models for you and put these models according to your requirement and try to connect them. So the thing left we are going to do is maybe we need to some way to examine if this is correct or not. Maybe it's a ERC-based or datasheet-based ERC plus mechanism or something like that. So the thing is that we are going to show the possibilities. So don't trust it. Again, don't trust the AI, but you can always use AI to do a lot of interesting things. Okay, this is probably what we are going to show today. So if you're interested in our distribution version, you can get the source code here. If you are interested in the plugins, the source code is also here. And if you are going to try the software, you can just download here. So far we support Windows. We do have a Mac version, but it's not stable. Always crash. And Linux, no, always crash. But try Windows first. Anyway, before we end talk, I will also introduce you another project we are making. So we are making open source hardware community for KiCad. There's two versions. One version is Chinese version. Another version is English version. Yes, it's called KiCadProjects.com. So basically, all the projects there is an open source project. You can always download, the schematic, PCB, everything there. So the purpose of this community is we are trying to make a hardware GitLab. We can say that. So it's a little bit like GitHub or GitLab, but it's only for hardware. We want to collect as many as KiCad project, open source KiCad project as possible, so that when you need something, you can have some place to check all the open source project you may use. So if you have interest, you can. This is Chinese version p.elecfans.com. So we embedded the latest viewer technology. So all the files there you can see the schematic PCB dynamically without a simple image. So if you have an interest, you can try this website as well. Okay, that's probably all for the presentation. So let's do a live demo. 这个可以投屏吗 ？Okay, so it's really small. Live demo is always frustrating and dangerous, but I always like to do that. So first, I like to show you the library panels. If you can see, so if you installed Huaqiu's distribution version, so you can see two additional icons there. So one is for the library, the other is for the Copilot. So if you open the library, you can see it's just a panel equipped with different components, right? So you can see you can just click the data sheet and it will open the data sheet for you. You can check all these metadata. It is linked with schematic symbols and footprint. If this component is linked with a supply chain information, it will always show there. It's not shown here because this component doesn't have a. Yeah, we can always do some search, and the search algorithm is quite good. You can search whatever you want, not only an NPN or some descriptions. You just search what you want, and you will get what you have. As you can see, after the search, you can see the supply chain information under there, right? If you want to purchase it, you just click the link, and it will navigate you to the online website, right? And you can directly place that component into the schematic sheet without additional configuration, and everything is there, right? The parameters. If you want to generate a BOM, you can generate the BOM according to the NPN plus manufacturer or the SKU of Huaqiu's SKU code. It will make your BOM simpler. So that's the idea. And this component panel also have a personal library. You can always, upload your own libraries there, and it's cloud-based, so you are able to visit it or access it anywhere. And this is the Huaqiu library we are talking about. We integrate a panel there, and their library, the quality of their library is quite good. Okay, you can see there's always things there, footprint there. After placement, everything is integrated, including the 3D models. The 3D models will be automatically linked to the PCB, so everything is settled. Okay, and I also show you, this is all about the component library. I'm also going to show you the module library. So we have maybe hundreds of modules there. So if you click these modules, you can see the live dynamic library sheet here. Some of them have schematics, some of them have a PCB. We haven't linked schematic PCB, but it's there. So there is a different categories there, if you can see, and you can directly place this thing onto your sheet as a snippet, or you can place it as a sheet. Yeah, so this is just basically the cloud-based library. Of course, you can always keep your own modules there so that you can access it anywhere. Okay, this is about library. Then I will show you something about the Copilot. Yeah. So this is a Copilot. So basically what you can do is, for example, this is a piece of power, right? You just select it. You can always ask questions here, but if you are not, you can just send this to the model. The prompt will be explain the purpose. I'm not sure if you can see clearly. We will extract the net list and the BOM, and use that information as a context and feed it to LM. Then he will answer the questions with you. Again, there could be hallucinations, so make sure you examine that result before you trust it. The thing is that it's not just a chatbot. It can do a lot of things. For example, if you click a symbol, there is quite a lot of Copilot commands here, if you can see. So expand the current symbol, find similar components, check symbol connections, check unconnect pins. So everything is there. You click and the area model will help you to answer your questions. For example, find similar object. Yeah. Oh, now it speaks Chinese. Anyway, so this is the issue of the prompt. So it can basically, find some alternative component for you. Yeah. So this is the basic feature of this Copilot panel, and I like to show you the image to symbol feature, which is quite cool. Let's see. This is a live demo, for example. So if we have an image like this is not very complicated, but quite complicated, right? So you could just directly copy this image, and you need to add symbol generator and just paste the image there and just send. So maybe we need 10 minutes or 20 so that it could be automatically generated. Let's see if that works. So we will identify the image. It's a 4-side or 2-side. If it's a 4-side, we'll generate a symbol for 4-side. Oh, it's here. It's quite quick. You can check it lively, or you can just place it into the schematic. Okay, I would say the accuracy is quite good. So if you have such a requirement, I do recommend you try this. And I'd also like to show a complicated one. That's an image to footprint generator. Let's see. So I just opened the Copilot panel. Let's find an image. For example, package, maybe this one. It is complicated, right? So it's a little bit complicated. So geometry is marked with some numbers here, and the real numbers is here. So we can just copy it and paste it into the Copilot. And here's what he's going to do. He will first trying to understand what is the correct type. For example, this is a SOT, SOP, or BGA. After that, it will try to extract these geometries from that image. Let's see. So there is an intermediate process. So let's see. He has, for this example, he has identified as a SOP. That's correct. So if it's not, you can manually select the footprint type. So far, we support all these types: BGA, DIP, PRCC, QFN, SON, QFP, SOT23. Right? You just click SOP. If it's good, it's okay. Then what you need to do is to check if these parameters extracted from the image is correct or not. You can always manually edit that or change that. If it's correct, you can just directly click generate, or if it's not, you can edit it anyway. So let's click generate. It's here. As you can see, we can then just place it into the footprint. Let me open all these layers. Show all copper layers. See? Show all layers. Yes, I will place it again. So basically, this is what we have done for the simple and the footprint generation. And the last thing I'm going to show you is the schematic generation. Okay, let's try. I don't guarantee it works, but at least we can try. It's a mermaid design. Let's see what we are going to design. For example, I want to design. Maybe a simple thing, a smart lock. This is, yes. So the models this is not a good requirement because I don't have dedicated, information. You can input any information you want. For example, you want to use the ESP MCU, you want the Wi-Fi or Bluetooth things, you just tell him what you want. You include these informations and he will try to pick up the correct module for you. Let's see. So this is the process of syncing. He is choosing the modules and he is trying to do the connections between different models. Let's see if it works or not. Connection diagram. It takes some time. Several seconds. Let's see what he can do by the end. Oh, there is a diagram table here. If you take a look, if I don't do anything, it will choose a microcontroller. There is a power, keyboard, and a lot of modules there. So if you think it's okay, you can just directly place that into your schematic sheet. Okay, if you take a closer look, the connections are there. Of course, you need to check if it's correct or not. And if you double click these modules, you will find, it's not just a container. So everything is there. So the modules are there. The connections are down through the root sheet here, right? So this is what we are trying to do. I'm pretty sure you have a lot of suspicions. You have a lot of questions. That's fine. But just as I said, this is just like an experiment or a trial for what LLM could do in the electronics industry. So in the future, I think if we can fine tune it, we can improve it. If our database is verified, is correct, we have a rich database of modules, solid information of components, is it a possibility to make a schematic sheet through LLM instead of humans? That's what we are trying to explore. Okay, so I think that's pretty much I'd like to see. I'd like to show. So we are doing a lot of interesting researches on AI and LLM and the EDA things, the data things. So I'm always open for discussion. So if you have interest in this, let's talk after this presentation. Okay? So I think time is okay. So let's see if you have questions.